Hello, welcome to the RedMars podcast. I'm your host, AstroJake, and today we're going to talk through, what we have in terms of kits, some deeper look at some of the projects I'm working on, some of the tools I use to get this done, and more importantly, the kits, the starter kits that I have been talking about. The first few are available on my Etsy store, so we'll talk about those, go through what comes inside one of these boxes, and talk about different things you can build with them, and really what kind of tutorials I'm providing with that as well. So we're going to have some fun, talk about these things, and just really what's going on, and we'll hop into some of the code and what you'll actually be doing when you get your kit, and really what you can do with them from then on out. So anyways, let's get started here. And as you will see, I have my website here ready to go. But before we kind of dive into that, I wanted to talk about a 3D printer I recently got. I know I mentioned it before. I just picked up the Bamboo Labs A1 Mini. I bought it from Micro Center, actually. They're not too far from where I live, so I wanted to give it a shot and see what it was like. It's more or less, it's a beginner printer, but I wanted to see if it would satisfy what I need it for, which is a lot of these smaller prints. So many people will say, oh, the print bed's too small to really print anything useful. I disagree. If you're working on small little projects like CubeSats and stuff like that, there's more than enough print bed space in there to use it for something fun. And really, this comes with all the upgrades you would want to make to a printer already done. And it comes with good slicing software, Wi-Fi enabled. Really, there's nothing you really need to do with it out of the box. It even comes pre-assembled, which is great. I don't know if anybody is familiar with like the older Prusa 3s and that. And you had to spend the first week putting the thing together, calibrating it, trying to get it to level. This thing auto levels kind of like a CNC where it touches the nozzle to the base plate, and does it all automatically for you, and it works very well. So I highly recommend it. Anybody who's looking to kind of get in the 3D printing space or looking for another more so desktop style printer. I got it behind me. You can kind of see there. There we go. It's tiny, doesn't take up much space. I did 3D print a little wall mount, so you can see that on the wall over there. That takes my spool, and that way I don't have to have the same depth behind it. So very simple thing I printed with one of my other printers, which you can see down beside me here. That's my Kiditech or Chiditech. I don't know how you pronounce it. It's QIDI. And that printer I've had for years. It works flawlessly to this date, and it works very well. It hasn't failed me. And that one's great because it's got an active heating chamber inside, so I can print some really kind of gruesome or rough materials. I do a lot of like nylon, carbon fiber, and stuff like that with it. But anyways, I printed the wall mount, and there's a little nozzle director. It's like a little tube with a trumpet-looking end that allows it to feed the filament to the printer without giving it all these weird angles, since it wasn't meant to have the filament come from that angle. Anyways, so did that just to help with some of the space. But anyways, where I'm getting at with this is I mentioned in the last one a lot of these different peripherals. I mentioned CubeSats and stuff like that. And I wanted to show everyone. So this is one of the CubeSats that I'm working on. Now, this is just a section of it. This isn't the actual full CubeSat, obviously. The rest of it's right here. Let me grab that. So this is the shell here. So you would have this section, and then you build your stack, and all your hardware goes in here. And then that goes in and mounts here. And then you screw it all together, and then more or less you have your CubeSat. But where does the printer come into all this? So you can print a lot of really cool parts, and I've printed this panel here, and it takes a Raspberry Pi, mounts to it, and provides you still access to your GPIOs. I also printed a panel where the solar panel goes on, and I'm going to have that so for all sides that I don't need to expose, they'll have solar panel for other residual power. There'll obviously be a battery pack on this and all kinds of other stuff. It's really just a test bed for playing around with different sensors and stuff like that. Now, the actual frame itself here is made of aluminum, and it's all anodized aluminum. And yeah, the kits that I was looking at, because I wanted to build a CubeSat, I wanted to see what it would cost to get something that's really a real CubeSat, but I wasn't actually planning on putting it into space. But looking at alternatives to a 3D printed model, something that is a bit more legitimate and would handle, say, the space environment, something like that. And so a lot of the models that are out there are CNC'd aluminum, and then you have to have the anodization or some sort of coating on it to prevent when you have like a plasma atmosphere and stuff like that, not atmosphere, plasma environment, you can have different types of sparring, arcing, stuff like that on different metals, and you don't want it to ruin your electronic components. And that's why I anodized it. But the prices were, thousands of dollars, $800 for a bare bones frame and stuff like that. And it was extremely expensive. So I tried to figure out a more cost effective way of doing that. And I'm able to make these for, around that $300 range, and then provide all the hardware and stuff with them. I'm not currently selling them, but if you are looking to build a CubeSat, I mentioned this in the last one, let me know. I can definitely get these made on an as-need basis, or if you need many of them or whatever, you're trying to build your own test bed and want to build your own kind of CubeSat as well. I can sell these for around what I pay and put into them, so around the $300 range, and get you one of these, print you some inserts if you need them as well. And yeah, maybe I'll make them available anyways, and just you can buy them through my Etsy account. I'll link them on my website, redmars.com. And then, yeah, again, just go to the RedMars Lab tab. That's what you see in the top right corner here. There we go. And from there, you can go to RedMars Labs and see all the different things that I'm selling. But I printed all these little inserts here with my newest printer, the newest member of my 3D printer family, and it's done a really good job now. It's got a textured print bed that's magnetic. You pull it off and you bend it, and then you can release your print. Here's another look at what that kind of looks like. Hold that close for you. Got both sides. This is an earlier print. I made some changes to it, but you can see where you have the spot for your GPIOs. That would be right here, and then this is the other side of the Raspberry Pi. And the Raspberry Pi's got its mount holes here, the 4 of them. Then this is for the pillars that go up, and you build your stack for your Raspberry Pi. Now, I made a new one just for some tests that I'm doing, and this one's gold. What I did was I threaded the 6mm holes that are along the bottom and the top, and you thread in one of these hollow M6 bolts, and I use a hex one because it's nice and round on the bottom. And what this does is allows you to feed a device through this that acts as a kill switch. So when your Raspberry Pi, your CubeSat is sitting in its stack waiting to be deployed, this provides a kill switch, so you're not draining battery power or anything like that until you actually are launched in your desired orbit. And what that does is, well, you can have 4 of them here, 2 of them, or whatever you want to do. You can have redundancy kill switches, but that just allows you to not actually run the CubeSat. It'd be pretty much completely dead until you get into your orbit. And when it launches, the kill switch will release and then close the circuit, and then pretty much power would flow through your electronics. It would come to life and do what it needs to do. And so that's a feature that a lot of CubeSats use. If not all of them that are actually gone into space. So that is why I wanted to do that. So the newest ones have that. So again, that'd be the newest model I would have on my Etsy store that has that feature, so you can play around with it and really just make whatever you want. They're a lot of fun, even if you're not planning to send something into space. It's just to build and tinker and explore. But it's cool to say, hey, I have an actual viable product that I could put on, say, a weather balloon and put into, the stratosphere or something like that. Or if you really wanted and put this into space for shorter duration missions, you definitely could do that as well. And obviously, you'd have to work on your electronics and make sure that your electronics are radiation hardened or anything like that, or at least redundant, so you don't have things failing on you. But for the duration of the mission, maybe you can just build in, enough error detecting code and stuff like that, and maybe it's sufficient for what you need it to. Another thing I printed with my printer is a kind of bracket that also goes into the CubeSat. How it works is, again, you have these 2 holes on the bottom, and that prints on or bolts onto one of the pillars, and that holds kind of like that. I don't have the screws in there, but you can kind of see how that mounts on there. Get you in the camera view. Pretty much that's it. And so print all these different little attachments that hold different peripherals, and these things then provide different types of telemetry data or functionality to your CubeSat so that you can make communications back home. So this is a LoRa, L-O-R-A radio. It works at the 915 megahertz range and is good for long-range radio. I'm not going much farther than my desk to maybe another room just for testing, but it is a way to transmit that telemetry, and I wanted to play around with making different types of antennas and tuning them to the 915 megahertz. So I have a VNA that I can use to, or VNF, sorry, that I can use to analyze the, frequency that it is tuned to or vibrates at for a given antenna, and then I'd work on the different radiation pattern with a spectrum analyzer and some other tools in order to know that it's doing what I want it to do. But that's a lot of fun that I'm going to be doing on, with this and that, and happy to share a lot of that with you. But the main thing that I wanted to talk about are these kits. So these are the RedMars this one's the Lunar Mission Kit. So I had some fun with them. Originally, I was just going to say, here's a kit. You can go build stuff with it. Here's some sample tutorials and all that. Then I started building these out, and I actually had a lot of fun with it. And when I do, different types of hiring like that through the different jobs I've had, I've always found myself in the role of an interviewer, and I enjoy it. I like to make it more fun rather than, here's a problem, do Fibonacci, show me how you do it, and then let's expand on that, make something more difficult. Can go through different algorithms, graph theory, stuff like that. All that really does is show that you know how to code and do algorithms based on what you did in university. Does that apply to everyday work life? More often than not, it does not. So I wanted to find a fun way to interview folks, and that's kind of where this comes from. So I like to follow a storyline, and so to find where all this stuff lives, so this is my website again, as I've shown you guys many times. Top right, we go to RedMars Labs. We scroll down here. You can get to the code. This is where the builder kits are. So this is the first one. It's the IoT ESP32 Lunar Mission Kit. And to give you an idea of what this kit entails, we have a storyline. So I'm just going to read this to you folks, and then we'll kind of go, and we'll go to both links, what the Etsy store looks like so you know what you're looking for and there's not something else you buy the wrong thing, and what my GitLab looks like right now. And obviously this will continue to expand as I have time and build out other ones like the wireless IR communications. That's probably going to be a Mars mission kit, and it'll follow similar not same storyline. It'll be based on Mars. But anyways, let's dive into the lunar one so you get an idea. So welcome to Lunar Mission ESP32 by RedMars Labs. This is a hands-on, story-driven electronic series built around the ESP32-S3, MicroPython, and your creativity. Here is the sample mission. So you have crash landed on the moon. With your main systems down and time is running out, you must rely on a handful of parts and your embedded programming skills to survive. Your only companion? Well, that's the ESP32-S3 dev board. You have some LEDs, a buzzer, and your ingenuity. Now, I'll just say, you do have other components that come in these kits. You don't just get some LEDs, a buzzer, and your ESP32, but for the first part of the mission, those are the components you need. All right. Can you build a beacon, signal Earth, monitor life systems? You are the mission commander now, so let's get to work. When my reading skills are not on point today. All right, so that's just a sample of what the kit is. So it's a lot of fun. You've crashed on the moon. Your landers, their systems are still functioning-ish, and you don't have much. Your comms are broken. Things aren't running right, but you're alive. And all you got, your little kit. And so what you're going to do is go through these different phases of your mission to try and signal Earth, make or demonstrate that you have comms, send an SOS. And once you get your comms back up, maybe you don't have voice yet, but you can get electrical signals through. So you try sending things like Morse code, and you go from there. So let's take a look then. All right, so this is where you find the kits. They are currently at $35 a piece. That covers my time, the parts that are in here, and I'm throwing other sensors in and all that. So it's more or less what I put into it is what I'm putting them for. I just want to get more people involved here. So it says that I have 5 currently available. If more are needed, I will make them as you need them. So there will be some time. Each one's going to be a little bit different. So you get your base components plus some extra peripherals. Maybe I throw in a radio. Maybe you get a servo motor and so like a motor control board, or you get little things. I do a lot of reviews of different types of components and stuff like that. And when I'm done with the review, they're going to go to you folks. So they will go to whoever buys these kits will get some extra parts. So this is where you'll find it. There's some images here of what everything looks like. And I'll just go through the kit kind of and show you as well. And so for the Lunar Lander kit, you get this little base frame. And it's kind of hard to see, but you got a couple tanks of fuel underneath. You have a rocket engine. You got 3 platforms. And then what happens is as you can see in the image, your control board sits on top, and that becomes your development platform. inside there. Then you get, a bunch of wires. It comes with your USB cable. It's USB-C to USB-C if you need an adapter. Probably don't. Most computers use USB-C now, but they do have adapters that go USB-C to USB 3.0. I think it's a USB-A or B, not A. Anyways, you get a bunch of jumper wires. You have a mini breadboard to build what you need to. They're black, which is kind of cool because usually they're whiteboards. It's fun like that. You get your control board, bunch of components, including photodiodes. You have LEDs, resistors, capacitors, buzzers. Really everything you need to build something and have fun. And then again, you'll get some other components thrown in there with every order, just as a thank you for making the purchase, and there's a QR code that is on here, which pretty much just brings you to my website, and then from there you can get to your RedMars Labs and go from there. So this goes through and just shows kind of what these kits looks like. If you want me to zoom in here, this might help just make it a little bit easier to see what it looks like when it's on top. A little breadboard, some jumper wires. There's more obviously in there. But yeah, a lot of fun. And yeah, that's what we are offering. Just to give you an idea, here's a Raspberry Pi kit. Obviously, there's a lot going on here. That's $640. People charge some ridiculous money for some of these things. I saw an Arduino one, and they were selling, I believe it was for like $100 or something like that. Obviously, you got a lot of peripherals in there, but I don't know. I feel like that's a bit steep, especially if you're just looking to get started. There's so much you can do with what is in this kit for $35. And the kind of code that comes with it and everything as well. Like, I don't know. I feel like this is very reasonable. All right. To the website. Or not website. My GitLab. All right. So this is the RedMars GitLab. Learn to build to explore. And exploring is what we do. All right. So I got 3 repos in right here. The RedMars IDE. I got a long ways to go on this. I wanted to build out my own IDE based on top of VS Codium. We're getting there. It's not there yet. No point in looking at this at this point. I haven't pushed anything to here. It's all local on my computer right now when I have time. Right now I'm focusing on these kits and getting some code out to you folks. So we have 2 things here. We have this microservice template for GraphQL. For those that don't have a kit, just want to play around, maybe you're computer science and you want to see how you can work with GraphQL and making a microservice, well, this is a great template to get you started there. For this, you're going to go to Lunar Mission ESP32. Click on here. And it brings you to your survival series on the moon. So this goes through, it breaks everything down. You have your 4 first missions. So you have a lunar beacon. This one is a blinking LED. You got your breadboard. You learn how to do pin control, which is GPIO control on your MCU. And this is that ESP32. You'll get to do things like set up a Wi-Fi app. And there's also a Bluetooth one. I don't think I have the Bluetooth one in here yet. But there's a lot of different challenges in here if you want to try and make it through Bluetooth and stuff like that. Yeah, you learn about Morse code. You learn how to handle inputs. Excuse me. What communication logic looks like. And a lot of fun. And, there's some other challenges in here like encrypted messages. Maybe you find out there are some adversaries that are trying to intercept your communications and not let you get your communications down to Earth. So instead you encrypt your messages so they can't tell which messages are what. There's a lot of fun here. So what you're going to do is you're going to come here, you're going to clone the repo using git clone. I suggest if you don't currently have what's called an SSH key on your computer, make the SSH key, and then you can clone through that. Otherwise, you can do HTTPS, which you need a username and password to clone it, or you can just download the zip if you don't want to make an account. Either of those is fine. Step 2, flash MicroPython to your ESP32. You're using ESP Tool or Thonny. I usually use ESP Tool, not Thonny, but you can use either or. A lot of people really like Thonny, so that one's there if you're familiar with it. I also do a lot of this through VS Code. I will say MicroPython's already coming pre-flashed on here, so unless there's a specific version you want to use, it's ready to go at the box. You don't have to flash it on there. All right, then you're going to go to each one of your missions and just really follow through it one by one. So yeah, why get one of these kits? Well, if you want to learn about programming logic, embedded design, just problem solving, and real world engineering, I'm trying to guide this around any types of real situations that could happen, especially with humans going back to the moon right now. comms are super important. So that's why we have started with, communications. And then with Mars, we'll have something similar and go from there. So if you go to each one of these, we can start with Lunar Beacon. Here is your mission. So we'll just talk about the first one. If you're interested, you can go look at the others. But so RedMars Lab, Operation Moon Base Rescue. So you've crash landed on the moon. Power is limited. Communication is down. All you've got is an ESP32 S3 dev board, a few components, and your wits. It's time to signal for help. You know that someone will be looking for you, and with ground stations pointing cameras at your location, you may be able to signal with what you have. So build an SOS beacon using MicroPython and an LED to signal for help. You will blink light in Morse code to transmit SOS. You will do this repeatedly. The supplies you will need. You will need your ESP32 dev board. Check. A breadboard. Check. An LED. Any color. Now, if you really want to get into this, you can look at what colors are more visible through space and choose that one. You got many to choose from in here. So pick a color. You will need a 100 ohm resistor. You'll need roughly 4 jumper wires, your USB-C cable for flashing your ESP32 with the code. And once it's flashed, you technically don't have to have it connected, but you will need to for power unless you have other means of powering your board, which you can do with many other kits out there. You can go on Amazon and just get an ESP32 battery kit, and it'll plug in, and away you go. And then obviously you'll need a computer and either VS Code, Thani, or something along those lines that you are familiar with. Again, these are coming pre-flashed with it, but if you're using a different board or anything like that and you just want to do this, or you already have an ESP32 and everything and you're just listening along and you're like, hey, I want to have some fun with this and learn, well, here you go. You can do that as well. So you can flash it, get things going, away you go. You're going to connect your LED. We walk through what you need to. So you got GPIO 4. Obviously, you can use any other GPIO. But we're saying use number 4. You need a 100 ohm resistor and then ground from your LED. So pretty much you go GPIO, 100 ohm, LED, ground, good to go. Then here's some code, some sample code for blinking your LED, just to learn kind of how it works, and then we'll go into the SOS portion. And so with Python, if you are not familiar, first of all, it's all space sensitive, so make sure when you use spaces, they are all consistent with your tabbing or spacing. You can configure your IDEs, to do a lot of this for you. Nowadays, you don't really have to worry. You tell it's Python, it knows it, it does it. But that's why you'll see all this indenting and whatnot. So this is for, you don't need any coding experience to get started here. This will walk you through all of it. And the sample code's here ready to run as you need. But anyways, so you're going to need some libraries, and they are listed here. So the first library is called Machine, and what you're doing is importing a part of that library, so you're not bringing all that in. When you say import time, really what this does is takes everything from this time library and plops it in on top when it runs the interpreter. I won't say compiler because Python is interpreted, not compiled. Although in a sense it'll be broken down to MicroPython. We won't get into it. Anyways, here's some sample code. This goes through just turning an LED on, pausing for some time. That's what this time.sleep is. And then you do LED.value 0. And what this is it's setting a high value on a output pin or a low value on an output pin, one being high. So you're applying some voltage, in this case 3.3 volts, over that pin. And when you go 0, that brings it back down to a low, which is more or less, we'll say 0 voltage across that pin, or coming from that pin. Then we go into building out the SOS in Morse code. So we call out what an S is. That's ... O is ... And the cool thing about this is Morse code can be transmitted visibly through light, electronically through pulses of electricity, orally it's all the same, through sound. You can do it all different ways. And it's super cool, and it goes back so long, used back in the day for communications during the war. They would even encrypt their Morse code. And so this is really the basics needed to get some information. And SOS is a good one to know, especially if you're ever stranded anywhere and you have light, a fire, anything, and you need to get that across. Just remember 3 quick, 3 slow, 3 quick, SOS. Anyways, we'll go through, we build this out. Then you go and do your mission debrief, which is you've built a functional optical beacon for rescue using limited resources. Your lunar survival chances just went up. But what's next? Well, mission 2, we're in Buzzer Base Camp. You'll use PWM to emit SOS tones and expand your beacon from light to sound or to light plus sound. And we'll go into, we know there is no sound in space. There's no atmosphere for sound waves to propagate. So the sound portion of this is based on being inside your airlock chamber in your lunar lander as some sort of health check to say, hey, I can hear things coming. So that is what we get into with Mission 2. And I'll just read Mission 2 so you can kind of see what's coming. So this is buzzer base camp. So outside your lunar module, your LED beacon flashes silently. Inside, the air is still until you wire up your buzzer heartbeat monitor. Not heartbeat as your own heartbeat, but for your systems. So sound can't travel in space, but inside your pressurized cabin, it sure can. Add a buzzer to your ESP32S3 using MicroPython and PWM. And it goes into what all this is. Create an audible SOS signal, a heartbeat ping, or a status alarm. It goes again into what you need, how to wire it, and the code to get this done. And you just keep going. So each mission builds on top of the previous. So we have 4 missions right now, and then they'll continuously get more and more complex. They step up pretty slowly between the lunar beacon and the silent SOS, and as you get into Mission 3 and Mission 4, they get a bit more sophisticated and complex, especially once you get into 4 and you start dealing with telemetry. And then we get into a web-based server that it gives you a basic web page to send Morse code, and that from your phone or computer to your ESP32, and then that message will get transmitted both on your LED for visible clarification, also from the buzzer for audible, and then in the code for that digital. So you'll have 3 different sources that are giving that message, and that helps you get noticed to try and get back to Earth safely. You know, it's kind of like a Mark Watney situation on the Mars. So a lot of fun. So these are the kits. And again, you get the kit, access to this code, you have a lot of fun, you learn how you go. Again, I will say that, and I mentioned it in RedMars Labs, if you are going on here to purchase your kit, there's this little section that says add your personalization. It doesn't really give me the option to add like add-ons really. So the personalization in this is being able to have parts pre-soldered. So in this image here, let me just zoom in again so you can see. You see these yellow rows. These are pin headers on the ESP32. And these pin headers do not come soldered to the board. It's just a bunch of holes, and then you get these and you would need to solder them. If you have a soldering iron or are learning to solder and you want to solder those on yourself, not a problem. Now, if you do not have a soldering iron or not planning on getting one and you want to have them soldered, then you can add, say, I don't know if I have specifics here. You can just say, please solder. Please solder my pins. Whatever. Something letting me know you want that pre-done. You'll say add to cart, and then I will see, okay, they want this soldered. And then I will solder those for you before sending it out, and you will get your kit ready to go out of the box. And that's really it. It's a lot of fun. The next ones are going to be using a different board. One of these guys. So this is a Raspberry Pi Zero. No, Pico. Sorry, the Zero runs Linux. This is the Pico, so a true MCU. And you can't really see, but it's got a little Raspberry Pi, or just Raspberry, but it's their logo on the chip itself. And these will be a lot of fun. Again, it'll have its own 3D printed structure that comes with it that for those next missions. But this is definitely your starting point. These will be a bit more complex and will be more for advanced and whatnot. That'll continuation from here. Maybe you manage to get your spaceship ready to go, but you have a new mission, and your mission is go to Mars. So we'll have fun with it when those ones come out, but that'll be a little bit of time yet still. So we're starting with these ones. These are your starter kits to get you on the mission and to the moon, and we'll go from there. So definitely pick these up. It helps me out, and it gets you in the field of building out some fun electronics for space. And everything you're learning here is really that entry point you need to go through to, if you really want to do this in a career. Maybe you're early on, maybe you're in high school, maybe you're in college, and you're like, hey, I'm not in the field of computer science or electronics, but I really want to try it out and see what I can do and see if I like it. Maybe you're looking at making the switch, or maybe you're already in your career and you're looking to upskill. This gives you the opportunity for all that to really get started and have some fun. And then when you get a bit more farther advanced, you can move up to something like this. If you're already at this point and you want a, structure for your CubeSat, then yeah, I'll put these on, and that way you can get started as well. And if there's some specific inserts you want for them, maybe you want to mount a Raspberry Pi in there, I can print out some of these inserts for you so that they come with your CubeSat ready to go, so you don't have to go and print out your own if you don't have a printer. If you do and you just want the bare bones, absolutely. This is all fun stuff and really enjoyable. So that is all I wanted to talk about in this one, and go through these kits and what they look like, what they come with, kind of some of the things I'm working on. And yeah, I want to wait until, a few people get these and start building them and get some feedback, and then we'll start building on top, and, we'll get the next 4 missions ready to go and added to my GitHub so you can have some fun. So again, link is redmars.com / redmars-labs, or just go to redmars.com and go to the top right corner, and from there you will see the RedMars Labs link. And there you go. Also from there, you have the projects by RedMars LLC. So that's the visit GitHub that gets you over to my GitHub and gets you started on those missions. Yeah, no, definitely appreciate it. If you following along here and you've made it this long and you are interested, definitely go pick one of these up. You won't be disappointed. And you're also helping support the lone engineer that is enjoying all of this stuff, and trying to make it as realistic as possible to what I do at work, and without obviously giving away anything too detailed, but the missions and stuff like that, trying to make these as fun as possible and as realistic as possible, and scenarios, things that could actually happen, with obviously some sci-fi thrown in there, because you got to have a lot of fun and let your imaginations run wild. So that is all I have for you folks today. Again, definitely check these out. Go visit my Etsy store. Let me know what you think. This is the first kit that's on there right now. There's other like 3D digital files and stuff like that that are from a while back. I'm really in the transition zone right now of that Etsy store as we move more towards these RedMars Labs development kits and whatnot. And some fun stuff coming down the line as well, looking at laying out my own peripherals that are more targeted on these development things, such as CubeSats and whatnot, that will be available for, really any of these development boards, your Raspberry Pi and whatnot, and it can be a lot of fun. So definitely keep an eye on it. Follow my store, and you will find all these fun things down the line. So with that, I hope you all enjoyed this. Give this video a thumbs up, follow along, subscribe, turn on notifications, and I will catch you all in the next video. Take care, everyone, and see you on the next one.